Okay, guys, so today we're doing probability trees. Okay, now what you did yesterday, or what you did a couple of days ago with the probability table, that comes into play here as well. So, for example, let's say I've got the probability of it raining is 0.8, which we know can also be written as 80%, and actually can also be written as 8 out of 10. Okay? If the probability of it raining is 0.8, we know from last time the probabilities add up to 1. So therefore the probability of it not raining would be 0.2. The probability of it not raining in percent would be 20%. The probability of it not raining in fraction would be 2 out of 10. Okay? So therefore what we're looking at here is the probability of something happening compared to the probability of something not happening. They need to add up to 1. Now, I'm going to bring in something that looks quite frightening to begin with, but bear with me. With this, if you can't see it, I've attached this question to your assignment, so you'll be able to look at the question if you can't read it from the PowerPoint here. Okay? So it says here, Hannah, make sure you can see it. Okay. Hannah is going to play one badminton match and one tennis match. The probability that she will win the badminton match is 9 out of 10. The probability that she'll win the tennis match is 2 out of 5. Complete the probability tree diagram. So, I'll ignore that to begin with completely and just say, what can I see here? So this is just about badminton here. So the probability that Hannah wins badminton is 9 out of 10. So the probability that she must lose badminton, does not win, these two here must add up to 1. So just like I showed you the previous example, it could be the decimal, percentage, or fraction. They've given it to us as a fraction here, so we need to use a fraction. So if that's 9 out of 10, to make them add up to 1, this must be 1 out of 10. Because 1 plus 9 equals 10. So it'd be 10 out of 10, which is the same as 1. So therefore, we've now looked at that and we've dealt with this. In fact, always in probability trees, that and that add up to 1. So now we look here. This is now about tennis. So badminton is now gone. This is about tennis. The chances of her winning tennis is 2 out of 5. So therefore we know that the chances of her not winning, these two will need to add up to 1. So if that's 2 out of 5, this part here must be 3 out of 5, because they need to add up to 5 out of 5 in this case, which is 1. Now, people often get confused with this part, but it's still tennis. So the fact of Hannah winning tennis is still going to be 2 out of 5 here, and her losing tennis will still be 3 out of 5 because it must add up to 1. Now, if you're a bit confused about what this probability table tree is even showing, it's basically saying if Hannah wins badminton, what's the chances of her also winning tennis? Or if she wins badminton, what's the chances of her losing tennis? Or if she loses badminton, what's the chances of her winning tennis? Or if she loses badminton, what's the chances of her also losing tennis? So the probability tree, the way you use it, is by going through it and by looking at the different options, which leads us on to this. Work out the probability that Hannah will win both matches. So what you do is you grab your pen and you start at here. For her to win both matches, she needs to win the badminton here, and then from here, she then needs to either go here or here. And because she wants to win both matches, she also needs to win the tennis. Now, I wouldn't go for that Hannah wins tennis, because that is only when you're talking about Hannah losing the badminton to begin with. So we must stay up here. So Hannah wins and Hannah wins. So because you want her winning both matches, what you care about is this and this. Now, when you work through the probability tree, you must multiply. So therefore, I've got 9 out of 10 here, and I will multiply that with 2 out of 5. So 9 times 2 is 18. 10 times 5 is 50. That's my answer. Probability of her winning both matches will be her winning badminton times her winning tennis. And that is your answer. If they asked us instead the probability of her losing both matches, I would go her losing badminton and her losing tennis. So it'll be that times that. Okay, let's look at another example. Right. Try this one if you want to first, by the way. Okay, Wendy goes to a fun fair. She has one go at Hoopla. She has one go at Coconut Shy. So that's Hoopla. This is Coconut Shy. The probability that she wins Hoopla is 0.4. Probability that she wins on Coconut Shy is 0.3. Complete the probability tree diagram. So again, you know that probabilities must add up to 1 here. So her winning Hoopla and her losing Hoopla needs to add up to 1. So if that's 0.4, this must be 0.6. Okay, then we go on to Coconut Shy. Now, if the probability of her winning Coconut Shy is 0.3, probability of her losing Coconut Shy must add up to 1, so it's 0.7. And again, down here is still Coconut Shy, so therefore we've got the same probabilities here. Probability of her winning Coconut Shy will be the same as up here, so 0.3. And probability of her losing Coconut Shy will be 0.7. Work out the probability that Wendy wins at Hoopla and also wins at Coconut Shy. So Wendy wins at Hoopla, so we're there so far. And then she either goes here or here now. And because she wants to win Coconut Shy as well, she must go here. So it'll be that and that, which is 0.4 times by 0.3, because when you go through the tree, you must multiply. That is 0.12. Use a calculator if you're not quite sure with that. Okay? Again, that's the answer here, by the way. If they instead asked me probability that Wendy loses Hoopla and then loses Coconut Shy, at that point I will go loses Hoopla 0.6 and then loses Coconut Shy 0.7. So 0.6 times 0.7. And that answer there would get me the probability of her losing both of them. Okay, last example. There are green and blue counters in a container. Kevin takes at random a counter from the container. He replaces the counter in the container. Kevin takes at random a second counter from the container. Complete the probability tree diagram. So, if that's 7 out of 8 here for green, that needs to add up to 1. You know that, so therefore that becomes 1 out of 8. And then because it's the same situation, this probability won't change compared to that. So if that's 7 out of 8 there, the blue must also be 1 out of 8. And again, same thing, 7 out of 8 here, so 1 out of 8 here. So if I said, what's the probability of him picking 2 blues in a row? You'd go blue here, and then you go either there or there, because you want another blue, it'll be there. And it will be 1 over 8 times 1 over 8 equals 1 out of 64. If I wanted to know what probability it was of 2 greens in a row, I'd do green here and then followed by another green. So it'd be 7 over 8 times 7 over 8 is 56 out of 64. If I actually wanted the first counter to be green, the second counter to be blue, I'd do that times that. 7 over 8 times 1 over 8 is 7 out of 64. And if I wanted to do first one blue, second one green, I do that times that. So 1 over 8 times 7 over 8 is 7 out of 64. And just out of interest, guys, what you'd realise, you don't have to do this, by the way, in the exam. Focus on what they want you to do for part B. But that plus that plus that plus that all equals 64 out of 64, which is 1. Okay? So that's just a little bit of info there just to show you with that. Alright? Anyway, good luck with this. Let me know how it goes. Do the forms quiz question, please.